Now, most stationary waves are obtained as a result of the reflection of the incidence wave. Now, any wave can be reflection and the incident can be a reflection of the incidence wave. Now, any wave can reflect just like light in such a way that the laws of reflections are obeyed. Now, if we proceed, in a stationary wave, some points are permanently at rest. They are called the nodes. Some other points vibrate with maximum amplitude. These are called your antinodes. You can see it from the initial diagram. These points where they meet, if you draw a straight line here now, this is the point we call, from that point we have it as your node. When two opposite waves meet, now this point that is being formed is what we call the what? Nodes and antinode. Here is the antinode, and here is the node. You understand? So they are being formed when stationary wave is being obtained. Now, distance between nodes and antinodes as also shown above. Note that the wavelength of the wave is twice the distance between the two nodes. Do you understand? Now, a node is a point on the stationary wave where there is no movement of the what? Medium. An antinode is a point in the stationary wave where there is a maximum displacement of the what? Maximum movement of the medium. Now, properties or characteristics of wave. By looking at the properties and the characteristics of wave. Now, under the properties and characteristics of wave, waves has the following characteristics or properties which can be examined using the ripple tank. You understand? The ripple tank too can give us these properties which we are actually explaining here. Now, they can also show the properties of refraction, diffraction, interference, polarization, which are also very good properties. Let's start with reflection. The reflection of wave can be shown in a ripple tank by directing plane waves from a wide diaper at a flat barrier placed in their path. If a curved concave reflector is used, the waves are brought to a single point called a focus. The barrier. Here is the solid barrier. You understand? Might have a shiny surface, no problem. But here, you have something like this. If an incident wave comes this way, this is the incident. This wave comes this way. Now, at this junction, this particular region is transparent. Not even transparent, but it has a shiny surface. Now, that tendency for that object to be thrown back, you understand, towards this direction. This is the incidents that are coming. Now, when they strike this surface, they were being thrown back towards this direction, thereby forming, this is the normal. This is the line, normal line. So this is what we call incidence angle, and this is the reflected angle. So if you go through that, this phenomena is what we call reflection of wave. For an object or for the actual direction of a wave to be changed, you understand, due to what? A flat barrier, a flat transparent, let me not use transparent, a flat mirror-like barrier, you understand? For it to change the direction of the wave towards the side, thereby forming the incidence and the reflected angle. This particular phenomena is what we call reflection of wave. Now, when we come to refraction, well, the knowledge of refraction is a little bit synonymous to this, but not that equal. We will look at it towards this way. Refraction is just like the direction of wave bending, just like one bending the direction of the wave. Let's say this is a wave incidence on this glass now. You understand? Now you decide to incident a wave on this glass. It goes in. By the time it's going to come out from the other side, it's not going to be straight anymore, but this way. This is the glass wave. I'm drawing the plan view of the glass. I'm viewing it from the top. If a wave is incident on this glass now, there is a change based on this surface. No two surfaces are involved. This surface A, this surface B. This is not going to turn upward now. It has changed the direction. When it gets this side, this one too has changed the direction. Now, at this junction, this is the incidence ray. Now, when it gets in here, the direction has changed. By the time it comes here, this place will become the what? Refracted ray. Meaning that this medium has actually changed the direction of that wave. So that this phenomena is what we call refraction of wave. That is the direction. But for reflection now, it's not passing through. It's being flashed back. It's being bounced back. You understand? Instead of bouncing it back to where it's coming from, it bounced it to another angle, thereby forming two angles. So this one too forms an angle. this angle can be incident angle, while this angle can be your what? Refracted angle. So when you get to practical, or get to our practical physics, you'll be able to see it more in a practical sense. Let's go. A plane wave in a ripple tank can be refracted by placing a sheet of glass. You can see that's what I just did in the water to make it shallower. Now, where the water is now shallower, the wave travels more slowly. If they cross the edge of the glass at the angle, they are bent or refracted and travel in a different direction. Refraction in the light is the result of a wave slowing down as it enters more denser medium. Another thing we need to understand is the medium which the wave passes through matters, because the denser the medium, the more curvy, you understand, the resulted wave will come out. That is, when I say denser, the thicker the medium, you understand, the more curvy, the more lighter the medium, the more straightforward the wave will pass through. So all that are being explained under our refractive wave. Now for our diffraction, let's go to diffraction, then interference. We'll be able to round it up. For our diffraction, if two barriers are placed in a ripple tank with a fairly large gap formed at the wide band of wave. Now the wave formed a beam at the wide ray. Now if the barrier are placed closer together to leave a narrow gap about one wavelength wide, the wave becomes different. You understand? On passing through that gap, it spreads out in a direct, forming a spherical. Waves are being incidented on a particular plane now. This plane has a small hole here. Now waves are coming in this way, this way, this way. You know, they are all now converging at this hole. Now this hole will now, this small passage will now be the one diffracting those waves. It will now spread them out. So this method is what we call diffraction of wave. This is diffraction. Very easy. That's the phenomenon whereby the wave coming in are being diffracted, are being spread out from a point. So that's just a diffraction of wave. Now for our interference, when two identical waves traveling in the same direction are superimposed or placed on top of the other. What do I mean? You will get to see it. If you look at it very well, two waves, nothing is disturbing them. One started from here moving and another starts from here moving. You understand? Now when these two waves are placed on each other, you get, they tend to what? Interfere. From interfere, the scientists came about interference. Now two interference mechanisms used to occur. There's what we call constructive interference and destructive interference. When does a wave tend to be destructive in terms of its interference? Look at it. Constructive interference could be when you match the two waves, they will now go like this. They will follow suit. This is a constructive interference. Are we getting it? Now if two waves have to travel in the same direction, or if one wave has to travel a whole number of wavelengths further than the other, so that they are in step. You see it, they are in step with each other. So this is a constructive. But for a destructive, they are not in step. You have something like this. They are being matched though, and now we just come this way. They are not moving in the same line. So this particular idea is called your what? Destructive wave. So at this junction, we have been able to dish down or break down every major topic in our physics, in our SS2 series. So we have been able to talk about a lot, and I want to majorly advise that for everything that has been discussed here, you just go through it step by step from our first topic in our SS2 series down to the end. I tell you, your SS2 exams or your O-level physics preparation is on a very good platform, because by the time you have this knowledge combined with your SS1 knowledge, I can tell you, I can really assure you that you are sure of what? A C or a B. I can show up with just the SS1 and SS2. So watch out for the SS3 series, which is the rounding up of the whole of SS.